Okay, so the first set of questions is all about, the difference between arithmetic and geometric sequences. Arithmetic sequences increase by adding or subtracting the same number each time. Geometric are by multiplying by the same number each time. So on the first one, describe it as an arithmetic or geometric, and then find the next three terms. So I want to look at it, and can I tell easily, is it by addition or subtraction? So to go from 100 to 60, I would subtract 40. But 60 minus 40 is not 36, so it's not arithmetic. So I would assume that it's geometric. So I would want to find R, which is 60 over 100, and reduce that down. And some people gave it to me as a decimal. Some people, when they were asking questions about it yesterday, as a fraction, this is 3/5. As a decimal, it's 0.6. It should be using it as a fraction. But if you gave me 0.6, I'm really not going to have too much of a hard time with that. And if I multiply by 0.6, if I take 60 times 0.6, do I get 36? I do. So this one is geometric. And then I have to find my next three terms. And that would be 21.6. 12.96, or 7.776, or as fractions, you get 108 over 5. 324 over 25, and then the next one would be 972 over 125. This fraction. Now, it would be reasonable to expect that if my first one was geometric, my second one would be arithmetic. It would be a reasonable assumption to do so. How do I get from 51 to 42? I would subtract 9, right? So D would be minus 9. To get from 42 to 33, subtract 9. So it does work subtracting 9 each time. So that's what I need to do to find the next three numbers. 24, 15, and 6 are my next three numbers. And this would be arithmetic. Okay. Questions? Now, they could both be arithmetic or could both be geometric. But if you have one, try the other one for the other question, because it would probably not be the same thing for both, but it could be. But that's where you want to start from. Okay, if the first one's geometric, I would guess that the second one's arithmetic, and I would try it. Now, it might not be, so don't assume that it automatically is, but it could be, and that would probably be the place to start. Okay, I mean, that's just test-taking strategy. Is, hey, I'm going to look at the other one being the other possible. I got two choices. I have two questions. More than likely, it's going to be one of each. No guarantees. But if I get one, I'm going to assume the other. I'm going to try the other one. That's my first guess. Okay. So these ones go to same idea, arithmetic or geometric, and what's the value for your difference ratio, your D or your R. And this goes back to recognizing the formulas. So this one, because it's a linear equation, it's arithmetic. And I have 12 times n, so my D is 12. And this one, because I have it raised to a power, it's an exponential. That would make it geometric. And the number that's being raised to power, my base is 3, so my R is 3. And that's, you have to be able to recognize the formula. You have to be able to recognize the equation as what type of equation do I have. Okay, arithmetic sequences. We know it's arithmetic. You're told it's arithmetic, so you're going to use the arithmetic formulas. One of the biggest problems students do on this test is use the wrong formulas. Use the geometric ones for arithmetic questions and arithmetic ones for geometric. And they will appear on the board exactly as they are here. It is up to you to know which one's which and which ones to use for what.
So they'll be here for the test.
They'll be here for the test. Okay, they will be there just like they are. And you have to know which one's which. Okay. Find the 120th term of the sequence. So that means I use this formula here. I need to know my first term, how many terms, which I know, and I need to figure out my difference. So to go from negative 15 to 8, my D, I take negative 8 minus negative 15, and I get 7. Okay, so my D is 7. N is 120. A sub 1 is negative 15. So A sub 120 is negative 15 plus 120 minus 1 times 7. And let your calculator do the heavy lifting. And you get 818. Yes, on this test, let your calculator do the heavy lifting. Number 5, write the first 4 terms of the sequence. Well, here's the first one right there. A sub 1 is negative 8. Yes, the first term says the first 4. A sub 1 is the first term. Rewriting that number is part of your answer. Okay? And then what do you start doing from there? You add 5 to each time. So A sub 2 would be negative 3. A sub 3 would be 2. And A sub 4 would be 7. Because what's the rule? The rule says add 5. So how do I get to the next one? I add 5. How do I get to the next one? I add 5. So you add 5 each time. Because that's what the rule says, to add 5 each time. And yes, restating the first number is part of your answer. Okay, find A14 in the sequence where A sub 2 is 4 and A sub 8 is 5.8. So, a couple of ways I can do this. My first thing I absolutely have to do, I have to find D. Okay, I have to find D. To find D, you take the last number, 5.8, minus the first number, 4, and divide that by the difference between the two, 8 minus 2. 5.8 minus 4 divided by 6, and I get 0.3. So I have 2 of the things I need to know. Now I have a couple of choices. I have a couple of choices from here. I'm looking for the 14th term. I could take 5.8 and add 0.3. Let's see, 1, 2, 3, 4, 5, 6 times to get 14. I could do that. Or I could find the first term by subtracting 0.3 from this one. Move backwards 1 to get the first term, and then I can go straight to this formula, which I think is easier than trying to add it several times. Okay. So A sub 1 is 4 minus 0.3, or 3.7. So A sub 14, the 14th term, is 3.7 plus 14 minus 1 times 0.3. And you get, sorry, I accidentally multiplied when I should have added. $7.6. To do number 7, find the two arithmetic means, in other words, fill in the blanks. So what you need to do first is you need to find D, the difference. Last term minus the first term divided by how many I need to go to get between the two. And I go 1, 2, 3 times, so it's divided by 3. So negative 50 minus negative 8 divided by 3, and I get negative 14. And then what I do, I just take negative 8 plus negative 14 and then add negative 14 to find the next one. Just fill in the blanks. I'm moving over by doing negative 14 each time. So I get negative 22 and negative 36. And if you are smart, you will do it one more time and see if you get the last term. And I do. Do it one more time to check your work. Because if you do it again and you don't get the number that's there on the end, the one that's supposed to be the next number to match the one that's there, you screwed up somewhere. Easy way to check your work. Oh, geometric sequences. So I'm going to be using these ones here. Okay. So it says find the 10th term of the sequence and state your answer in simplified fractional form. So what do I need to know? I need to know my first term. A sub 1, 27. N is 10, because I'm looking for the 10th term. And I need to find R. And to find R, you take a number divided by the one in front. Okay. Does she need to go now, or do you have the cart? I do. She's going to need it. She's on cart. Oh, okay. Great. Yeah. Yeah, take your stuff. Sorry, Lily. This will be posted later.
All right.
Okay? And you can email me questions because you can't walk up to my room very easily.
Science test.
Just do your best. Just do your best. And you know that's all recorded, right?
Oh.
Yeah. Maybe I should pause. Okay, so to find R, pick a number, divide it by the one in front, and I get R is negative 1/3. Okay, that's how you do it. You could also look at it and reason it out other ways. If I have 1 as one of the numbers, the one following it's R. And if it changes sign, then R is negative. To go from 1 to 1/3 by multiplying, I multiply by 1/3. 1 times whatever will give me the next term. That's an easy way to find R. Okay? Then you plug it into here. So A sub 10 is 27 times negative 1/3 to the 10 minus 1 power. Now, I had a couple of kids that were having a hard time with this one the other day, getting it to come out as a fraction. Okay, so if you take 1/3 on your calculators, most of you, okay, 1/3. Yeah. Many of you, your calculators, some of them will work, some of them won't, giving you the fraction. But remember, if I want to do 1/3, and that would be to the 9th power, I take 1 to the 9th power, and I get 1. I take 3 to the 9th power. You can do them individually. You don't have to do the whole fraction. You can do the numerator And then you could do the denominator to that power. So you can do 1 to the 9th power and then do 3 to the 9th power, and you get 19,683, and it would be negative. And then you do that times 27, and you get negative 1 over 729. Question number 9. You're given a very important hint on how to do this problem. Do the first 4 terms. The first one, n is 1. So a sub 1 is 5 times negative 3 to the 1 minus 1 power. 1 minus 1 is 0. Negative 3 to the 0 power is 1. 1 times 5 gives me 5. Do not make the assumption that it's the number in front, because if your power is not n minus 1, it won't be the number in front. Plug 1 in for the exponent and simplify. It's the best thing you're going to do to get it right. Okay. A sub 2, 5, negative 3 to the 2 minus 1 power, negative 15. Plug in 2 for your exponent, 2 for n. Okay. A sub 3, the third term, 5 times negative 3 to the 3 minus 1 power. 3 minus 1 is 2, negative 3 squared is 9, times 5 is 45. And then a sub 4 is 5 to the negative 3 to the 4 minus 1 power. Let's see. And that equals negative 135. Plug in 1, plug in 2, plug in 3, plug in 4 for n in the formula and figure out what it is. And let your calculator do the heavy lifting. Find a sub 9 in the geometric sequence where a sub 3 is negative 500, a sub 6 is 4. Couple of ways to do this, but you absolutely need to have r. Your first thing is you have to figure out what r is. R is the root of 4 over negative 500, and it would be the cube root because 6 minus 3 is 3, so it's the cube root of that. Okay. And you get negative 1/5. So that's your R. Now you have a couple of choices. Geometric sequences aren't going to be very far down the line. I'm not going to ask you to find the 20th term to go from 6 to 20. I'm not going to ask you to do that. I could figure out what the first term is and then plug it into here, or plug it into this one, plug in 9 up here, go back and figure out the first term and do that. That's really a lot more work than it needs to be. Realistically, here's what you're going to do. You're going to go from the 6th term, which is 4, there's the 7th, there's the 8th, and there's the 9th that I'm looking for. I'm looking for that one. Multiply each time by r. So negative 1/5 times 4, negative 4/5. Multiply that times negative 1/5, and I get 4/25. And multiply that times negative 1/5, and I get negative 4/125, and that's your answer. It's easier with the geometric just to multiply, because you're only going to multiply 2 or 3 times to get to the number you need to get to. It's not going to be that far down the road. I'm not going to make you find the 300th term. So the 300th term would be so teeny tiny it wouldn't matter. Okay. Find the three geometric means. You have to figure out what r is, and then just multiply -6 times r, and then again to fill in the blanks. To find r, I have 1, 2, 3, 4 jumps, so it's the fourth root of the last one. -32 over 27 divided by 6, -6, sorry. And you let your calculator do the heavy lifting. Or root, parentheses, 32 over 27 divided by 6 in parentheses, and you get r is 2/3. Let your calculator do the heavy lifting. So times -6 gives me -4 times 2/3 gives me -8/3. 2/3 gives me -16 over 9. Figure out r. You're taking the root of the last one divided by the first one. And in this case, the fourth root, because we have 3 blanks, and you have to move over 1, 2, 3, 4 times to get to the fourth, to get to that term. That's why it's the fourth root. Let your calculator do the heavy lifting, and then just multiply. Okay, arithmetic series. So it's arithmetic, so I'm going to use the stuff from this column. It says find the sum. Oh, the sum. I need 3 things. I need to know how many, and the first one and the last one. Well, how many do I have? I have 91. To find the first term, a sub 1, let n equal 1. 2 times 1 plus 18. My first term is 20. A sub 91, the last term in my sequence. 2 times 91 plus 18. It's 200. So the sum of the first 91 terms is 91 divided by 2 times 20 plus 200. And you get 18,200. Same question, same idea. I need the same 3 things. I need to know how many. I need to know the first one. I need to know the last one. I know the first term. I know the last term. What I don't know is how many. I go back up to this formula up here. Plug in the last term, plug in the first term, figure out D. How do I get from one term to the next? I add 6 each time. So my D equals 6. So I go, okay, 148 equals 10 plus n minus 1 times 6. So distribute, combine up like terms, add, you end up with 144 equals 6n, n equals 24. So there are 24 terms in that sequence. I'm adding up my first 24. So the sum of the first 24, 24 divided by 2 times 10 plus 148. If I subtract 10, I get 138. Distribute the 6. I have 6n minus 6.
One of the minuses.
And then, yeah. So 158 times 24 divided by 2. And you get 1896. Simple formula, but you have to have all the parts. First, last, and how many. If you have first, last, and how many, you're good. Questions? Okay. Geometric sequences. Find the 8th term. Okay, so geometric means I'm using these to find the sum of the first 8, sorry. I need to know the first term, I need to know R, I need to know how many. Okay, well n is 8 because I'm asking for the 8th term. The first term is negative 15, sorry, it's 15. And then R would be negative 60 divided by 15, which would be negative 4. So R is negative 4. Plug it into the formula. The sum of the first 8 is the first term, 15, times 1, times 1 minus negative 4 to the 8th power, divided by 1 minus negative 4. Don't do it all at once. Do it one part at a time. Use the parentheses. Make sure you're typing things in correctly as far as your negatives and positives go. So I always do the part in the parentheses first. 1 minus parentheses negative 4 in parentheses to the 8th power. And that gives me what's inside, times 15. And then the denominator, 1 minus negative 4 is 5, so I divide that by 5. And I end up with negative 196,605. Next one, find the sum of the series from n equals 1 to 9 of 3 times 2 to the n. Same thing, use this. I need to know what n is, that's easy. The number of terms, I'm adding to the first 9 because I'm going from 1 to 9. I need to know r. R is 2 because it's 2 to the nth power. The number I'm raising to the power, that's my r. My first term, a sub 1, is 3 times 2 to the first power. Do not make the assumption, this is the most common error, is assuming that it's just the number in front. Plug in 1 for your power and make sure you have the right first term. In this case, it's not 3 like most people assume, it's 6. And then use the formula. The sum of the first 9 terms is 6 times 1 minus 2 to the 9th power over 1 minus 2. So 1 minus 2 to the 9th times 6 divided by negative 1 gives me 3,066. Most common mistake is assuming that this is the first term. Not necessarily. Depends on what the exponent is. If it's n minus 1, it is. If it's not, and just make sure, plug in 1 for n and figure out what the first term is for sure. Okay, performance task. You bought a plot of land on a hillside for a Christmas tree farm. You analyze the dimensions of the available land and determine you will be able to plant 60 trees at the base of the hillside, the first row, and there will be a total of 25 rows of trees. You calculate that for each row, you'll be able to increase the number of trees by 4. Given this information, answer the following questions. Is this best modeled using the arithmetic or geometric sequence? How do I get from one row to the next? What am I doing each time? I'm adding 4, which would mean that this would be arithmetic. Okay, it's an arithmetic sequence because I'm adding 4 each time. Okay, write an explicit equation you can use to calculate the number of trees in any given row. Write the equation form a sub n equals. Fully simplify your final equation. So because it's arithmetic, this is the one I'm using here. I need to plug in the first term, I need to plug in D, and then simplify. My first term is, how many trees do I have in the first row? How many trees do I have in my first row? 60. How many am I going up by each time? 4. So a sub n, that's a horrible a sub n is equal to 60 plus n minus 1 times 4. Now, there's an extremely important line in this question here, and it says, fully simplify your final equation. That is not simplified. Distribute the 4. A sub n is equal to 60 plus 4n minus 4. A sub n is equal to 4n plus 56. Distribute, combine up like terms, fully simplified. So that's the answer to the second part. And to make sure I get to use it, because I'm going to have to change pages. A sub n is equal to 4n plus 56. Right, down over here to the side. Okay. So using that formula to answer the next 2 questions. What is the 13th, or a sub 13? Ooh, a sub 13 is 4 times 13 plus 56. Use the formula we just came up with. N is 13. Okay. 4 times 13 plus 56. Get 108. How many trees will be in the last row? I.e. the 25th row. What is a sub 25? Plug 25 into there. 4 times 25 plus 56. 4 times 25 is 100 plus 56 is 156. Should be able to do that without calculating. How many total trees will be on the farm? The total of all the rows, or S sub 25. That kind of should give you a hint. I'm going to use one of these 2 formulas here, because these are the 2 with S. I'm going to use the one that's arithmetic. This one here. I need to know how many rows, 25. I need to know how many in the first one, 60. And how many in the last one, we just did that. So the sum of the first 25, 25 divided by 2 times 60 plus 156. 60 in the first row, 156 in the last row, because that's what we just figured out. And you have 2,700 trees. Questions?